Dear students, today we will solve another problem of Bode plot. So, unity feedback system is given, that is 10 divided by s of s plus 1 s plus 10, right. So, first step, that is time constant form, or else it is also called as corner frequency form. That is, if you are having simple pole or simple 0. So, simple pole means s plus 1 or else in bracket s plus 10, these are simple poles, only single s is there, for that we call as pole at the origin. Similarly, in the numerator also we can have, for that we call as zeros, right. Now, s plus 1 format we should have. In the denominator s we are having in s plus 1 only, but another term, that is another simple pole, it is s plus 10. So, in order to convert that into s plus 1, so we should remove, we should take 10 common, right. So, 10 and 10 will get cancels, numerator 10 and denominator I am taking 10 outside in order to make s by 10 plus 1, that is s plus 1 format, right. So, 10 and 10 will get cancel, what will remain? 1 divided by s of 1 plus s by 1, then 1 plus s by 10. Okay, this is first step, time constant form, right. So, next is step 2. So, put s is equals to j omega. So, wherever s is there, replace it by j omega. Say whatever the time constant form is there, take that, then replace s by j omega. See here, I am replacing s by j omega. So, s is replaced by j omega, as you can see here. Then find out the corner frequencies, right. That is in the bracket 1 plus j omega by 1. So, that is your T1. So, omega C1 is 1, means omega C1 is equals to 1 by T1. Okay. Similarly, second bracket simple pole, that is 1 by j omega by 10. So, there j omega by 10, it is omega, sorry, T2, that is omega C2 is equals to 1 by T2. So, omega C2 will be 10. So, step 3, that is factor, or we need to find the factors, k is equals to 1, then we are having simple pole, then we are having pole at the origin, that we need to identify. So, that is identifying factor. So, k is equals to 1, we are having s term in the denominator. So, that is pole at the origin, then we are having two simple poles, right. Then k is equals to 1, we are having two corner frequency, right, omega C1 and omega C2, right. Then k is equals to 1, so 20 log k. So, we are writing in terms of magnitude. So, 20 log k, that will be 0 dB, okay, 0 dB per decade. So, intersection of Bode plot with dB axis. So, you can see here magnitude of initial slope plus 20 log 1, 20 log k it is, right. So, 20 log 1, that is nothing but you will get 20 dB. Okay. Similarly, this one, right, that is pole at the origin. See, pole at the origin, you can see here, pole at the origin. So, one pole, that means if you are having pole, add minus 20 dB per decade. Okay. So, previously we are having 0 dB, right, plus minus 20 for this pole, right. So, initially always take 0.1, because you are using semilog sheet, in that first one corner first line we are taking it as 0.1 at the initial line. So, 0.1 we are taking as a starting point, then end point is omega c1. Omega c1 you can see here, omega c1, that point. So, next after pole at the origin, next step is simple pole. So, simple pole, previously we are having minus 20, for this simple pole again minus 20. So, it becomes minus 40 decibel per decade. So, here, so starting point whatever previously we are having end point, so that we are taking as starting point, that is omega c1 1, then this 10th end point, this is omega c2. Okay. So, whatever the value we are getting now, same value we are taking here. Okay. And the end point 10, that is nothing but omega c2. Similarly, next is third simple pole, that is third simple pole means minus 20, previously we are having minus 40. So, minus 20 plus minus 40, you will get minus 60 decibel per decade. Okay. Then here starting point is 10, because previously we are having end point as 10. So, we are taking same value as starting point. So, third pole, that is minus 20, pole means already told minus 20. So, previously I was having minus 40, again for this pole minus 20. So, it becomes minus 60, right. Then starting point, that is 10, because previously end point was 10. So, from that we got this 10, then there is no next omega c3. So, it becomes infinity, right. So, next is phase angle plot. So, whatever the transfer function that we got, right, the same thing I took here, which is where s was replaced by j omega. So, same thing I took here, k is equals to 1. So, angle if you check, then 1 plus j 0. So, angle will be 0. Similarly, for this j omega, that becomes 1 by j omega here. So, 1 by j omega, it is 90. So, that is r plus j omega, r plus jx. If you apply the formula, then you will get 90, but it is in the denominator part. So, when you take it upside to the numerator, it becomes minus 90, right. So, next is simple pole, that is 1 plus 1 divided by 1 plus j omega by 1. For that, the formula is tan inverse of omega by 1. So, for this numerator, we have got tan inverse of omega by 1, right. So, once you take from the numerator, once you take it into the denominator, it becomes minus tan inverse of omega by 1. Similarly, for another simple pole, 1 divided by 1 plus j omega by 10. So, tan inverse of omega by 10. So, when you take it on the numerator, it becomes minus tan inverse of omega by 10. So, these are the some values, 0.1, 0.3, 0.5. You can take your own values from 0.1 to 100, or else 0.1 to 1000 also you can take. Okay. So, for this omega value, we have put the values. See here, we have got the values here, minus 90, then this minus tan inverse of omega 1 by 1, minus tan inverse of omega by 10. So, same thing, put the omega values, you will get the angles. You will get the angles. Okay. So, semi-log sheet, I had drawn the reference value minus 20, minus 40, minus 60 and plus 20 line. Right. Now, first step, that is k is equals to 1, that is 20 log k, we got 20 decibel, right. So, that we are going to draw here, 20 decibel. So, after drawing k is equals to 1, that is 20 log k, next is simple pole, that is 1 by j omega. So, keep the scale at minus 20. Pole means keep the scale at minus 20, as you can see here, right. So, keep the scale at minus 20, Then draw the line from point 1 to omega c1. So I am keeping the scale at -20. For simple pole means -20 decibel per decade. Similarly, zeros means +20 per decade, right? So I kept the scale at -20 per decade. Then I draw from point 1 to 1. Point 1 to 1 because 1 is omega c1 value. Similarly, next is simple pole. Simple pole -40 decibel per decade. So keep the scale at -40 decibel per decade. Then draw a line from 1 to 10. But you should extend that line. See, -40, I am keeping the scale. The same thing, same parallel line I am taking from that point, that is from 1 to 10 because omega c2 is 10, right? This is -40 decibel per decade. Similarly, third one, you can see here, third one -60 decibel per decade. So keep the scale at -60. Then see, I am keeping the scale at -60. So same the parallel line I am drawing here, but there is no next corner frequency. So just draw a simple line. It will go till infinity. So this is magnitude plot. Similarly, we'll draw phase angle plot. So by taking 1 -180 reference line. See here, -180 reference line I will take. So above -150, 120, -90, below -210, -240, like that. So -180 will be our reference line for all the problems. Then so for so many omega values, we are having so many omega values here. You can take your own omega values. For that you got some values also. So put that values for point 1. Then for point 3 it is -108.41. For point 5, like that. Put all the values. Point 3 -108.5. One, then 0.6, 10, like that. Put all the values. Then draw freehand line for that, right? So this is your phase plot. So we have drawn magnitude plot, phase angle plot. Now you can see here, so 180 reference line, to that this phase angle plot is intersecting, right? So this intersecting point, take a straight above line which gives you omega pc, that is phase crossover frequency. Then this bc, point b and c, that will give you gain margin. Okay, similarly here 0 dB reference line, your gain plot which is intersecting 0 dB reference point. So this point, take a straight line. So here we will give omega pc, that is omega gc, gain crossover frequency. So this line -150 to this reference line. So this is your PM, that is phase margin. So for any doubts, please you can let me know. Thank you.